just started a competition. We have Texas A&M International University. I'm going to call them TAMIU on the A1 side. We have Colorado School of Mines on the A2 side. I see movement from Colorado. Colorado has a tracked rover. TAMIU drives on a drum. Drives on a drum. Okay, I see movement from TAMIU. Meanwhile, Colorado School of Mines has gone past the obstacle field. They need to get their digger into the mining area before they can start digging. The digger is in the back of this robot, so they're going to have to turn now. The robots are actually randomized in their starting position. They don't know whether they will be facing forward or backwards or sideways. Thanks for joining us. Colorado started to turn their robot. Okay, there's Colorado still turning the robot. On the right, that's Colorado School of Mines. On the left, that's Texas A&M International University. Oh boy. From this angle, you can see the track on the Colorado School of Mines robot. Kind of looks like it might be coming off the track there a little bit. Can they recover from this? Can Colorado School of Mines recover? That's their digger. Their digger is a ladder bucket ladder. Are they over the line? Can they dig right there? Only the judges know for sure. Yes, it looks like they are over the line. So they might as well dig. You can see the regolith pouring into that robot's bucket, into its hopper, onboard hopper. That's Colorado School of Mines. This is their second official attempt of 2. Colorado School of Mines has been here 6 years. They have never missed a year of this competition. Three and a half minutes into this 10-minute competition. Colorado School of Mines is lifting up. There goes TAMIU. We saw some movement from TAMIU right there. Wow, look how far Colorado's digger went down there. They dug pretty deep just then. The deeper you dig, the better your chances are of getting some gravel that we have buried. The judges have buried gravel underneath this fine regolith. The teams get more bonus points if they get gravel. The gravel simulates icy regolith under the surface. When NASA sends a robot like this that's there to excavate regolith, when we send a robot like this to another planet, that icy regolith is like gold. We can turn that icy regolith, we can pull out the hydrogen and the oxygen molecules. We can make rocket fuel out of it. If we can do that, we won't have to bring all the rocket fuel with us. We can make some while we're there. That's called in situ resource utilization. That's a fancy scientific term that means living off the land as much as you can on another planet. ISRU and NASA speak. We like to use a lot of acronyms at NASA. Here's a reverse angle of TAMIU's robot. It's moving a little bit. Must be having some trouble with its locomotion. This is the view that the team can see, the team of operators in the control room. They can't see it with their eyeballs. They're not here with us. They're in the control rooms behind us. They're in enclosed trailers. All they can see are computer screens that they brought with them. There's TAMIU's. You can see they have an auger system for their robot. The teams are able to see 2 camera feeds that NASA provides them. Those camera feeds are from the perspective of the lander that dropped the rover off. They cannot see the reverse angle like we can see. That's TAMIU in control room A1. And this is Colorado School of Mines robot. There's Colorado School of Mines team in the control room. They could see clearly that their track has come off its sprocket. And so it appears that they are not going to try and recover from that, because it did not look like they had hands on their computer just then. We have 3.5 minutes remaining in this 10-minute competition with Texas A&M International University on the left, Colorado School of Mines on the right. Both robots have moved. Colorado School of Mines crossed the obstacle field on their tracked robot, got all the way down into the mining area, and then when they were turning their robot sideways in order to dig, this happened. You can see in this video that their track has come off. So they went ahead and they did some digging, and it looks like they had a respectable dig there. Just having some track issues. This is their second and final official attempt, though. Second and final attempt for both teams this week. But I gotta tell you, even if a team does not get any regolith, if they don't meet the 10 kilograms required to qualify, it is not a loss. These teams are university and college students. They have spent all year designing these robots, building these robots, bringing these robots to KSC to compete in this competition. They've spent days working in the pits behind us here. By the way, the pits are open to the public if you want to go browse through them. You'll see the robots close up. This is not a loss, even if they don't qualify. The experience these teams have gained is immeasurable.